All right, welcome everybody to Unit 2.3 video lesson. Today we're talking about absolute value transformations. So this is going to be a little bit different than what we did in 2.2 because these are all done graphically, okay, which is why we have a little bit of a different setup here today. Now we only have two rules, okay, which is a nice change from function transformations. Okay, so our first rule, okay, if we take the absolute value of an entire function, okay, meaning we put absolute value bars around the whole thing, okay, the portion of the graph below the x-axis will be reflected, leaving the portion above unchanged. Okay, so I just want you to write down your rule for right now. Okay, so the portion of the graph below will be reflected up, okay, and whatever is above the x-axis will be unchanged. So the notation of when we take the absolute value of the entire function will look like that. That's how we'll know. Okay, so you're essentially taking the absolute value of y, of the y values, which is why anything under the x-axis, those would be the negative y values. When you take the absolute value, those would come out to be positive, and they would need to be reflected to the top of the x-axis because now all of your y values are positive. Okay, and this down here on the bottom is what this would be an original function would look like. Okay, and then you see here your notation for taking the absolute value of the entire function. And so then we would put bars around everything here. Okay, we're going to use transformed table of values like we did in 2.2 in order to create our original graph. But then that is what we're going to use to graph our absolute value transformations. Okay, so let's take a look at an example. Okay, so graph A is my original function. Okay, this is a quadratic. So in order to graph that, I'm going to make a table of values. Okay, so quadratic uses -2 to +2. Okay, now I see in my equation I have one transformation, so that's shifting the graph down 4. So I'm going to subtract 4 from my y values. Okay, so we know those are the two columns that are going to make the ordered pairs I'm going to graph. Okay, so this is a parabola. All right, so that is my original graph. That's what I'm going to now use to take the absolute value of the entire function. Okay, so the rule says anything below the x-axis in the original function is going to get reflected up to the top. Okay, and anything on the x-axis or above it will remain unchanged. So I like to first recreate whatever points are on and above the x-axis. So -2, 0 would remain unchanged, and 2, 0 would remain unchanged because those are on the x-axis. And then the ends of my parabola here would also be unchanged because those are above. Okay, so I like to recreate that first. Then it says you take these points from down below and you reflect them upwards. Okay, so -1, -3 will now become -1, +3. 0, -4 becomes 0, 4. And 1, -3 becomes 1, +3. Okay? And so you see this bottom portion shape to the parabola is now up above the x-axis. We're just going to recreate that shape from the points that we reflected. Okay, so that graph now in B, that has taken the absolute value of the entire function. Okay, time for our second rule. Okay, so the second rule now says, if you take the absolute value of only the x in the function, okay, the part of the graph to the left of the y-axis will be replaced with a reflection of the graph that appears on the right. Okay, and the right side will remain the same. So it's similar to what we did in the first rule, where everything above the x-axis stayed the same, and then we reflected below. Now we're going to reflect to the right, okay? And everything on the left will disappear, and the right will remain the same. Okay, so our notation, so here's what your original function would look like. That's just the equation of a parabola. Okay, and now here's your function notation. So you see how this is different from the first rule. Our absolute value bars are inside because we're only taking absolute value of the variable. Okay, so you see that over here. So before they were on the outside of the entire function, now they're just on the variable. Okay, so let's try our second rule. Okay, so here's my original function. Okay, and again, I'm going to use a table of values to graph. So a parabola, -2 to +2 again. And I see this time it's a horizontal transformation. So I'm going to add 2 to my x values. Okay, so those are my values to graph. Okay, so there's my parabola. So now, to apply my absolute value transformation, okay, it says you keep everything that is on the right side of the y-axis. Okay, so all this portion of the graph that's on and to the right of the y-axis, we're going to recreate, just like we did before. Okay, so we're recreating the portion that we keep. Before it was above the x, now it's to the right of the y. Okay, so you see that we've erased the end of the parabola over here. Okay, we're not keeping that because the rule says get rid of the left side and now replace it with a mirror image from the right. So we're going to take this portion that we recreated on the right and we're going to mirror it over to the left side as well. Okay, so obviously 0, 4 is our meeting point. 1, 1 becomes negative 1, 1. 2, 0 becomes negative 2, 0. And 4, 4 becomes negative 4, 4. Oh, and I missed one, sorry. 3, 1 becomes negative 3, 1. There we go. Okay, and then I just connect the rest of my graph. So this looks like a W now. That is my final graph when I'm taking the absolute value of just the x for this function. Okay, it's important for rule number 2 that your graph, your original graph, always touch the y-axis. Okay, you want to make sure that your graph, goes far enough onto the y and even past it so that you know where that middle meeting point is that you're reflecting over and what portion of the graph you are doing away with. Okay, so now we're going to do a couple examples where we put both of these rules together on the same function. Okay, so first we're going to graph an original in part A, and then we're going to take the absolute value of the entire function. So this should be like that. Okay, so this is a square root function. Okay, so when I make my table, I'm going to use positive values that are perfect squares. Okay, so I'm going to use 0, 1, 4, and 9. Okay, and I see that I'm subtracting 2 from the y's and adding 1 to my x value. Okay, so those are my ordered pairs. So let's see what I can fit on my graph. So 10 would maybe be somewhere out there off the graph. Okay, so there is my absolute value. Okay, so now to take absolute value of the entire function. Okay, we keep everything on and above. So we're going to keep 5, 0. And we're going to keep 10, 1. Okay, so I put that one just so I'd have more than one point above. Okay, so I'm keeping those. And now these two guys, okay, that portion of the graph that's below, we have to reflect that up to the top. Okay, so this is rule number 1. Whatever's below the x-axis is getting reflected up. Okay, so 1, -2 is going to be 1, +2. And 2, -1 will be 2, +1. Okay, so this is curving upwards in the original. So we want to curve it down a little bit when we reflect. Okay, so we're just trying to maintain the original shape of the function. Doesn't have to be perfect, but don't just make it a straight line. Okay, so that's what the graph is going to look like for square root when you take the absolute value of the entire function. Okay, so now we're not done with this example yet. Okay, we're going to use that same original. So I'm going to try and keep both of these in frame. Okay. Here we go. Nope. Not there. Okay. And now we want to take the absolute value of just the x. So we're basing it off of this same original. Let me get rid of this. Okay, so we don't have to recreate a new original function. Okay, we're just gonna base it off of that graph we already have. Okay, so this is now rule number 2. And this says that we keep everything on and to the right of the y-axis. Well, now, this function can't actually get to the y-axis because that would make it undefined. So we're going to have a gap there, which is okay for this. But the last time we did rule number 2, that function could actually extend to the y-axis, which is why I said we wanted to make sure that it touches. Okay, so we're recreating everything on the right side here, which is this entire function. Okay, so 1, -2, 2, -1, 5, 0, and our 10, 1. Okay, all right, so we don't really need our original anymore. So we can move this up. So we recreated everything on the right side of the original graph. That's what this was. Okay, and we just used part A from this example to do it, so we didn't have to do the parent again. Okay, and now rule 2 says take all of this and also reflect it to the left side. All right, so 1, -2, reflect, 2, 1, 2, -1, okay, 5, 0, and then our 10 is somewhere out here. Okay, so both pieces of this are part of the final answer when we take the absolute value of just the variable for this function. All right, so far, part A, part B, and part C, we've seen before. Okay, part D now, I'm just going to darken this. Okay, this is brand new. We haven't seen this now. So now this is both rules in one. Okay, so in part D, this is now assuming Okay, that graph C is the new original function. Okay, so this is now saying, well, pretend that this was your original graph. Okay, because you can see that inside here. You can see that function here. And so that's really saying, well, if this was your original, and all we've done now is take the absolute value of your entire function, well, this is really rule number 1 now. Okay, so again, inside, this looks like the equation that we graphed in part C. So if we pretend that this is our original, then all that's being asked in part D is to take the absolute value of the entire function, which is rule number 1. Okay, and rule number 1 says take anything below the x-axis and reflect it upwards. Keep whatever is on and above. Okay, so on and above, on each side, a little squished over there. And then we're going to reflect all of these points up. Okay, so 1, negative 2 becomes 1, positive 2. 2, negative 1 becomes 2, positive 1. Okay, and we can connect all right, and then we have negative 1, negative 2. We're going to reflect upwards, and negative 2, negative 1, that goes up top as well. Okay, so that would be the completed graph for part D. So again, think of part D as taking the absolute value of a new original, which was the equation from C. So you can really apply the rule to any graph if you just tell yourself, okay, well, this is the original graph now. Apply rule number 1. Okay, let's try this one more time with a different kind of function now that might visually make things a little bit easier. Okay, so this is a parabola. So we're back to the beginning. This is an original function, it's just an f of x. So let's make a table. Okay, so that's our parent function for a quadratic. And I am subtracting 1 from my y's and adding 3 to my x. Okay, so plot my points. Okay, now I'm going to make sure that I extend this to my y-axis. So I want to know what's the y-intercept of this graph. right? It's going to be 0,8. So I want that because I know in the future, when I do rule number 2, I'm going to need to reflect across the y-axis, and I'm going to want to make sure I'm touching that. And that's our very top point there. And so you could mirror it over here if you wanted as well. All right, so there's my original. So now part B, you're taking absolute value of the entire function. Okay, so that means everything below gets reflected to the top, and we keep the points that are already above. Okay, so we're keeping those, and just this one point that's below, we're going to reflect up. Okay, so this was rule number 1. Everything below goes up. Okay, so now same as before. Maybe I can put these side by side just for a second here. All right, that's a little bit better. So here's my original, okay? And now for part C, I want to take absolute value of just the variable. Okay, so I'm going to take this graph, keep everything on the y-axis and to the right. Okay, so this is why I had you put that extra point in. And then we're also going to reflect it over here. Okay, so when we do part C, we're actually eliminating this portion of the graph that extends to the left side of the y-axis. Okay, so I'm going to keep this in frame while I recreate it over here. Okay, I'm keeping on and to the right of the y-axis. Okay, so I'm keeping all of those points, not extending past the y-axis. Okay, all right, so now I don't need my original anymore. And in addition to keeping everything to the right side, we want to reflect it over. Okay, so in the middle here, it doesn't go past that point. It just meets kind of at a hard V. Okay, and that is your final graph for part C. Okay, so now part D, remember how we think about that. Okay, we now say C is the original graph. Okay, because inside that equation matches what was over here. So that's the original. And now it looks like we're taking the absolute value of that entire original function. So that's rule number 1. Okay, and rule number 1 is reflect everything that's below. Okay, so we're going to keep all of these points that are on and above the x-axis. Okay, so we can create that portion. And then that one point that was below over here, okay, that's going to get reflected up. And then we're going to do the same thing on the other side with the other half of the graph. Okay, everything on and above the x-axis stays as it originally was. And then the point that's below is getting reflected up. Okay? All right, so this is everything from 2.3 absolute value transformations. Okay, we're definitely going to do a lot of practice with this, so please do not panic if you are struggling at this point in time. Just make sure that all of your notes are complete. Okay, I will see you guys next time.